What's up, everybody? Welcome back. Today, I want to work on using compute shaders to generate geometry so that I can render SVGs faster, so that I can anti-alias them with multi-sampling anti-aliasing, so that I can have pretty icons for when I write a taskbar for my Wayland window manager that we're writing from scratch. Simple. But like the real, task for the day is OpenGL compute shaders. So this is our SVG renderer, right? We are using this so that we can render icons for applications. One of the things that we might want to do here is we might want to make it not look like shit, right? It looks so bad around the edges. And there's like many ways to tackle this problem, but what I wanted to do was multi-sampling anti-aliasing. I think that's like the easiest, simplest thing to do. And so maybe if we're rendering like a 512 by 512 image and we want to do, double that resolution in X and Y so that we can multi-sample, then you start getting into like the realm of 1024 by 1024. And you can see like, I don't know if it shows up on screen, but you can like feel some lag at this resolution, right? Like it's starting to like become a noticeable amount of render time. And so what I wanted to look at was, can we parallelize the SVG render? And I think it's like disgustingly parallelizable, right? To summarize what we are doing to render this thing, we are kind of extracting a bunch of components of a path, right? So, I guess here we can kind of show the outline, right? So we have each of these like areas between dots, is like a new curve. And what we do is we go line by line, and on every line, we solve all curves, which is like maybe stupid, but we say like, what is like the intersection of this curve with my scan line? And what we do is we kind of say for each curve, we are going, like, can we look for somewhere down below? We are going to, can we change the color of this again back to like green or something? We are going to notice when we cross at the bottom of our pixel and the top of our pixel, right? So we go over every curve, we'll write down all the points where that curve crosses us, right? Then we kind of pair up enters and exits and turn those into like winding changes, where we say every time we enter exit, I guess this is downwards, we subtract one. And if we enter exit upwards, we add one. And any time that the fill in the middle fulfills some rule, like it is not zero, then we fill it in. And so what we are really doing is something where each intersection test is independent. So each intersection test with each curve is independent, and each line is independent. So what is this? If we're rendering at what, like 1024 lines, and maybe we have like 15 curves, that is something that we can do, let's say 16. That's like, we can do that many things at one time on GPU. And it's like completely free. Right? Seems pretty fucking sick. And then also we can like generate geometry on the GPU. We are then also, by the way, we are then on CPU right now, like stepping in between these things. We're saying we go along this line, set each pixel according to the winding order. So again, that's like massively parallelizable as well, where you can say on GPU, just like run your pixel shader for all of the filled in pixels, and to like figure out which pixels are filled in, you could probably do all scan lines at once in a GPU shader or something. So that's the idea I want to play with. I've never done this before, so I want to try. I think like you can basically use an OpenGL compute shader to write rules into some buffer somewhere, and then like consume those as part of your render loop. So I want to take a look. Did I miss why the top of the logo is flat, or explain that right now? I believe that is because if we render the outline, that's probably a bug. That seems like a bug, because I would expect this to render based off what I'm seeing here. So I'll have to go back and look at that. But good eye. I just didn't notice that until right now. Okay, So the plan is, let's generate some geometry and render it with a compute shader. Then let's try to use SPIRV, because all of this like solving logic where we try to find all these intersects, that's like a lot of Zig code that we've already written. It would be nice if we could reuse that code in our compute shaders, which I believe is possible. I'm not 100% sure, but I think it's possible. Then once we've got that, we can use the geometry shader or like the compute shader to generate geometry that will like render an outline for us, which is like a good first step. And then we can go from there and do like the fill rules. That's the plan. We'll see how it goes. We'll see how it goes. Oopsies, that's not done. All right. So I'm gonna be a bit of a lazy piece of shit because I kind of like know that these compute shaders exist, but I think that like finding an example that does exactly what I want might be a little bit of a pain. We can ask the idiot for an example, which is cheating, I know, but we aren't gonna just take it blindly. You know what I mean? Can I get an example of using an OpenGL compute shader to render, let's say, a circle, a line strip of a circle? Because like when I looked up the examples before, like the idea of like stitching the compute shader to the rendering was like not super straightforward. So I just want to make sure that like we get an example that's kind of along what we wanted to do. So what's he doing? He is generating a buffer for, you guys probably can't see that very well, huh? Okay, we'll copy paste this somewhere so that we can zoom in on it. Set file type is C probably. Okay, so he is generating a OpenGL, like essentially just data buffer that he is binding as shader storage. Got it. He's like uploading some data to that. I don't really give a shit about that. He is creating a uniform buffer. Interesting. So instead of using uniforms normally, he's creating like a uniform buffer for them. That seems kind of crazy. Can we ask him to not do that? Because I don't think that's necessary. I don't think. Let's ask him, can you make it so that in the, what do we call this? In the, like that the input to the shader is just a vertex ID, and then we calculate the position with cosine in the shader. We shouldn't need a crazy uniform buffer. I assume that this is allowed, but, you know, I don't really know. Like, give me something fucking simple. This is not helpful. Fuck you. Okay, we're gonna ignore that, because this was... We actually immediately regret our decision because he's just not doing what I wanted to do. But it seems like we can bind a shader storage buffer and then create a compute program that exports that thing. And the compute program looks very similar to a vertex shader that we've seen before. I've never seen this like layout modifier thing before. But I guess let's just kind of fucking run it and see what happens. Fuck the idiot. I should never have tried. You know, we always regret it. Okay, let's just do this in our existing application where we have all of our OpenGL context set up and stuff. Can we do compute shader? And what's he doing here? He's got parameters output. Okay, I assume that when we run this thing, we're gonna run like one thing per unit of work. We're gonna have like 1,000 threads, we can call them, quote unquote. We have inputs and outputs, it looks like. And he's just got some position buffer here that he is writing the output to. And so I assume that we should just be able to bind two buffers, input and output. Except we don't even need input buffer. We only need output buffer for our initial example of rendering a circle. Right right? Where we have, it looks like you have an ID that comes in as your dispatched, right? He says, I've got some invocation ID, which we can use to flag where we want to be. We want to specify our output position. I don't really understand this like layout thing. Compute shader, OpenGL. Let's take a little peek. Do they all use that like layout thing? No, they just use like normal inputs. Oh no, these are built-ins. Can we look at maybe this guy will tell us? The layout specifies stuff like padding restrictions. Yeah, I guess that makes sense, but like why I don't do that in all of my other OpenGL shaders. You know what I mean? So like why would I do it in these ones? You know what I mean? Like, does this have any like examples of shaders? No. Compute shader example. Maybe we'll look at the learn OpenGL ones. Yeah, I think I'm just gonna rip it, and we'll see if it yells at us. I think that's the plan. Well, layout buffer is interesting. Oh, I see. Maybe the buffer command is something I've never seen before. So, because I see. Because like usually you're in vertex shaders, you're binding like one parameter. But here you're binding like a fuck ton of parameters. And so you need to specify the padding between them where you wouldn't have had to before. Sure. So can we look up like GLSL layout command? Like, what is this STD 430? You know what I mean? Like, what does this mean? Did somebody give us a source? Here we go. Okay. This layout alleviates the need to query the offsets for definitions. The rules of the SVG 140 layout explicitly state that the layout arrangement of any interface block declared this layout. This also means that such an interface block can be shared across programs, much like share. The only downside of this layout type is that the rules for packing elements into arrays and structs can introduce a lot of unnecessary padding. These are covered quite well by the spec. Okay, and then they say, blah, blah, blah. This SVG 430 is like 140, except with a few optimizations, the alignment and struts for arrays and structs of scalars and vector elements. Specifically, there are no longer rounded up to a multiple of 16 bytes. So an array of floats will match C++ arrays of floats. Beautiful. Beautiful. I like the sound of that. I don't think you depend on it. You don't use uniform buffers, which are often written from CPU buffers of structs, but I think I will, right? Because I think eventually the inputs to this thing is going to be all of my SVG render rules, right? So I will eventually have a struct. So understanding this is probably worth it. And I guess they're kind of saying that like the spec is like the real source of truth for this thing. And then buffer. Like, where is the definition of this like buffer rule that they're using? Do I even care? Fuck it. We rip it and we just see what happens. Okay, so this seems reasonable, I think. Let's see. So we are saying, hey, I want to put in a vertex of this thing. We have binding position 0 with the nice buffering layout. And I guess why do we have to name this? Because am I using that below anywhere? Like, what is this? This is just a name for us, right? We're like naming the struct? Or is vert out a keyword? No, I assume, like, is it optional? Can we look up, like, GLSL, like, I don't even know how to, like, call what this is. Like, input declaration? Core language layout. Okay, variable types. Definition. Bum 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 bum. Where do they have an example of this like crazy thing that we're seeing? Oh, out data. Here we go. Oh, so here they define a structure here. Is there the buffer keyword? Is that even in here? Is this made up? Should we even trust the idiot? Yeah, let's go back to the learn OpenGL example. Let's go back here. Because I don't necessarily trust the idiot. The idiot's an idiot. You know what I mean? You know what I mean? Okay. I mean, he's only doing a uniform output as well. Buffer is shader storage buffer RSE. Shader storage buffer GLSL. Aha. Okay. Gotcha. So what is layout name here? Like, why does that have to exist? You know what I mean? Like, I'm not going to use that anywhere, right? Right? Am I crazy? Like, it seems like a completely useless word to me so far. We can ask the idiot again, because we're lost. Why do I have to specify a layout name when using a shaders, what is it? Shader storage object or something? Shader storage buffer object with OpenGL shaders, or GLSL shaders, I guess. Or do I even? Like, you usually don't have to write a layout name. Rely on implicit binding field mapping or explicitly specifying. Sure. Yeah. So why the fuck do I care? Am I fucking high? Oh, is this just a name? I'm just fucking high. This is just the name for looking up, right? Because nothing else in here is the name of a parameter. I'm a fucking idiot. Sorry. Brain just not on. I just usually call these something else. So this would be like output. I see. This is just a name that I can refer to this thing, which I would usually lowercase, and like maybe you would like prefix this with something. I figured it out. We're lost. It's okay. Okay. So let's say we want to parameterize the number of segments of the circle. I think that makes sense, right? So him actually using use segments here makes sense. Is that what he did on the first pass and I was just like fucking stupid? No, he did all sorts of parameters. But yeah, this is silly, I think. He's got the parameters of a circle, like kind of saying like I can give you like 400 of these at once. But I'm like, I don't want that. I just want like one set for everything. So I think I should still be able to use uniforms here, right? I think. Well, we'll try that later. For now, we'll just hardcode the number of segments. We'll just hardcode everything. So if I is greater than 20, fuck off. Here we are trying to find some time step around number of segments. So can you declare constants in this language? Can you do like const float num segments is 20? I guess is an int. I think you can do this. I don't fucking remember. And then we will say radius is 0.5, I guess, for OpenGL space. So that kind of covers this guy. Okay, center, we'll just keep it 0. Fuck that shit. Then we write that shit out. Okay, sure. Let's just try that and see what happens. Okay, so we want like a buffer for this thing. And we want to kind of bind this thing. Is that what they were doing? They bound this as a shader storage buffer, right? So we should be able to GL bind buffer. as a GL storage buffer, like this. Okay. The fuck is he mad about? Probably try here. Then he sets the data, but we don't have to set the data because it's output, right? So we don't give a shit about that. Then he binds it with GL bind buffer base, which I've never seen before. I've never seen this before. Bind a buffer object to an index buffer target. Okay. So we are trying to bind a shader storage buffer. Index 0, I assume, is what we're using here. Null pointer does not set it, allocates it, which is what you want. Oh, I see. That's a pretty good point, huh? Because, like, I guess we need to pre-specify from our side that there's enough room to put this shit. I see. So here we want, like, 20 times size of F32 times 2, probably, right? Or 4, because 4 floats per output, right? I guess we're, like, really, like, relying on some rule here. Oops, that's the wrong thing. Yeah, good call. We do need to allocate the data. Okay, so we're doing... I want the thing that is currently bound to GL shader storage buffer, so fix me. Surely we should be using the named versions of these, right? That's much nicer, but for now we will do what everyone does and use the shitty stateful version. Here we are trying to do 20 times 4 times size of F32, so times 4, I guess. This is null, and then we are saying dynamic because, sir, you are allowed to write stuff out, right? That's invisible. Why are we not syntax highlighting? Am I high? Okay, yeah, I guess I am. Because that's compiling. I don't know why he's mad. Okay. GL bind buffer base. So we are using the thing currently bound to this place in like the global index, ew gross. We know that the thing is hard-coded as index 0. And the buffer, name of a buffer object to bind. What is he doing? He is using, oh, right, the buffer. I'm a fucking idiot. Sure. So here we're saying, what? Oh, so first we bind this buffer, our buffer, to shader storage buffer. Then we like set the parameters, completely unrelated. Like we could do like GL bind buffer 0 here to like unclear, right? We could clear the binding here, I think. And then this is saying, okay, now that you're good, we have a shader storage buffer at index 0, this buffer. I guess. But like, isn't... usually I thought that these bindings were like tied to the program in some way. Maybe that's just for lookup. Okay, cool. So we have to like compile this program. Surely. Which he is just like stubbing out. Great. Do we have the learn OpenGL example though? Where does he compile his compute shader? GL create shader, shader source, compile shader. Oh yeah, interesting. I guess there's no like vertex shader, fragment shader linking together. Because it's like we just know that it's a compute shader. That's cool. Okay. So we should be like GL compile shader. With I guess we need compute shader is GL compute shader. Create shader, compute shader. Something like that, right? And then we're like, set the source of this thing to compute shader, which we should call this source. Okay. Easy. Then we compile shader, easy. Surely we need to bind this to a thing, right? So we're like, bind this to the compute shader. We have one thing at this address, and I don't know what this null is. I can't remember. Oh, the an array of string lengths. Oh, we're saying I don't give a fuck, just like use null terminated strings. Sure. Fuck it. Blaze it. Okay. Then we can check compile errors, but we don't really have. I mean, how do we do that when we do it usually? Oh, we have a nice little check shader compilation. Cool. Look at us go. Okay, what's he pissed about? He's like, I expected a double const pointer to U8. I found a double const pointer to U8. Fuck it. 420 blaze it style. Okay, let's just like run this and see what happens. I guess we did need to define that we wanted GLSL 430 or whatever the fuck. Where do you specify that? It's like use core or something, version 430 core. There we go. Okay, that compiles. It doesn't like freak out, so that's good. And then we need to link the shader after somehow, right? Where's this guy? Compile. So we need a program, which I think we actually can attach to our allocators. I think also we want to defer a GL like delete shader, because this is temporary, because like once it's bound to the program, we don't need it anymore, or something like that. It's like something like that. He's calling attach shader with like some global ID. What the fuck is going on there? Does Zig do anything fancy for strings, or just C style null terminated? Well, I mean, usually it doesn't use the C style. It like appends a 0 to every string that you make for C interrupt, but usually you have like pointer and len, so that you have like bounded arrays and stuff like that. But yeah, it doesn't have like a special string type or anything. It's not like Rust where you have like the UTF-8 validated strings. It's like you just pass them around as byte strings, and if you want to interpret them as UTF-8, you can. This is just attaching it to a program. So why the fuck were they typing ID in all caps? Am I high? Oh, they just put it in all caps here, and I was like, I assumed that they wouldn't do that. Okay. So we attach our compute shader, and we link the program. And then we probably have to get a little mad. Why is he mad? Oh, try here. We have to freak out if something goes wrong, which it seems like they just use check compile errors the same way. But let's check what we do. We call check program link. Okay. So if we are lucky, nope, he's like, compute shader must contain a fixed or variable local group size. Okay, what the fuck does that mean? Oh, I see. So like how so this is telling us like how many pieces of work that we are bundling with one shader execution. Interesting. Cuz like this is still technically, I guess, thinking in terms of like 3D space, even though we're not thinking of it that way. Sure, we can just kind of slap this on the top and figure it out later. Okay, cool. So it compiles and links. Beautiful. And now we should be able to run it. So how do they execute this thing? Let's use the program. And it seems like there's no like vertex array object equivalent, right? There's no like converting, like setting up how to bind the data. I think we just bind this buffer like right when we're going to use it. And then we should be able to just fucking rip it. It seems like. That's how it seems to me, but like, what the fuck do I know? So here we're saying dispatch compute, please. And we want to execute 20 steps of this thing. It does like 3D dispatch for some reason, because like I guess that's convenient. And like maybe you can kind of optimize like memory usage of your chunks of work if you kind of know how they're going to access the data that they're working on. So there's like a world where that kind of makes sense, but we are not doing that. So we are just going to treat it as one-dimensional and try to say, generate me 20 things. And I guess now I want to be able to like read the data back to prove that we did something that I understand. So can we do that? Like OpenGL read data from buffer, right? That's like a thing that you're supposed to be able to do. GL get buffer sub data. That sounds familiar. Which is slow as fuck. You're not really supposed to do this very often, but in our case, fuck it. You know what I mean? We don't care. We're just like trying to confirm this is right. Okay. So we are like, give me buffer. I want to start at 0, and I want to pull in, I guess, 20 times 4 times 4 bytes of data, and I want to put it in floats. So this is going to be 20 times 4 times 4 F32, right? And we are kind of hoping that if we print this thing, it looks kind of like a circle. I guess we have, let's just do a if true return here. Just to stop all the other shit. Okay, that's interesting. So we do see like some stuff that looks like initialized data, but then some other stuff that like very much doesn't, right? And we see like one, we definitely see like coordinates here, right? So this is like a 3D vec4 here. Here, you can tell because the ones in between mark like the homogeneous coordinate, which is always 1. Right? So we do see 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm an idiot. No. So it should be 20 elements, right? That's what we asked for, times 4 parameters per element times 4 bytes per float. That seems like it should work. Can we print them a little more formatted, I guess? I times 4, 0 to 4. Oh, wait, that's fine. Oh, because I don't need the times 4 here. Because this already has the times 4 because it already knows the size. Yeah. You're right. That looks pretty good, right? We see something that is 0.5 in X, then like a bunch of like, interpolated shit, 0.5 in Y, a bunch of interpolated shit, negative 0.5 in X, negative 0.5 in Y. So that seems pretty freaking good. Seems pretty good. So I guess the dream here is that we then can use this buffer as a source of render data for the next step. Right? That's the dream. So instead of reading this thing back, I think I've read somewhere that you need like a memory barrier. Maybe that was in the idiot's version of the code. Yeah. I'm just gonna trust for now. We'll say, idiot says we need this. Didn't think about it. But it seems reasonable, right? It's like, hey, we want to like make sure that the stuff that we computed is synchronized in some way. Okay, so we want to attach this buffer to some like render source. And so we have like, well, let's just try to draw this in our debug widget for now. I think that's like the easiest place to do this. So we'll for now just shove this somewhere as hold, I'm thinking. Solid color render program, I think is the thing that we have, which is like there we go. And then we can have like a circle source is going to be some vertex array object that we call a render source in our world. Okay. And what is this guy expecting? He is like, thinks he's like tied to some vertex format, right? Which is interesting. That is interesting. So what is this guy expecting? He's expecting a vertex, which is just a struct that holds two points in it. So can we maybe... yeah, okay. There's a lot of... I think we're just going to sidestep this whole abstraction for now, because I'm not really sure if it works. We'll do it manually. Which means that we need to do something like vertex array object is allocators root GL create vertex array object. Okay. And this is going to set up kind of the binding between the data and the program that we want to use, right? Yes. So can we look at that like solid color program? This guy is hold vertex shaders here. Can we do in here specify like layout index is 0 or something so that we don't have to, so we can just like hard code it? I mean, we know this is going to be a 0. This is going to be 0, so I don't have to think about it. Okay, so we're trying to say open GL render triangle example. Should we wait? Shall we wait some more longer? Okay. Where the fuck do they tell me how to map this shit together? Here. Okay. This is what we were trying to do. We were trying to say, we have some buffer full of shit, right? So we should be able to say, bind this buffer as an array buffer. I think that you can just copy it over, kind of no big dealio. You can say this same buffer that we used for compute output, let's use it for array buffer now. We want to set the data, but we already have the data in there, so we don't have to do that, right? Then we are like, let's set us some attributes, bitch. I guess that means that we probably have to GL bind array as well, because we're like setting parameters on it, surely. I don't know what, they didn't have that. But vertex attribute pointer is kind of like the key of this thing. This guy says, hold on. He basically says, how do we map the data that we got back to what you expect? So he's like, I'm at index 0. I am giving you floats that are too long because our program is expecting 2 floats per input. The type is a float. Great. Are they normalized? No. Fuck off. The stride, 2 floats. Right? And the offset is 0, which in this world is called null. And then we say enable that thing. No, the stride is 4, actually. Right, because our vertex shader is outputting Z, or sorry, our compute shader is outputting 4 float parameters, but we only need 2 in our inputs. So it's like we have 2 in, but 4 wide, or something like this. And then we should be able to break this thing and say break block. You know, let's make a render source, and this guy's just a wrapper around a vertex array object. And I think he has a len associated with him as well, if I remember correctly. Yeah. So our len is probably 20. We have 20 points, I think. It's probably something like this is what we want. I'm really like just guessing. So we'll call this a generated circle. Is this beautiful? I wonder if buffers are implicitly immutably typed according to the target they're bound to, the same way textures are, or if binding the same buffer to different targets works. I think that I saw... I mean, isn't the whole point of this thing that we can use it that way after? Where is our learn OpenGL compute shader example? Is it this one? Oh, because he's rendering to a texture. Yeah, it is worth asking the idiot. You're right, that is a concern. Drawing from an SSBO directly isn't a core feature. Commonly, you copy it does say this, right? Or use buffer texture transforms. These approach also bind a VBO and have the compute shader right into that VBO, created as GL array buffer and shader storage buffer. Oh, interesting. That's interesting. Please elaborate. Storage buffer, blah, 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 blah. So here, he's got buffer here and here. Vertex shader reads from pause. Beautiful. CPU side, create 1 buffer and use it for both. That's what I want to do. So he creates pause buffer here. Same buffer. I mean, he's saying you can do it. I mean, this is exactly what I'm trying to do, right? But then we'll say like it seems like he's saying what I'm trying to do is okay. But we don't trust him, but I trust him enough to try it. And if it doesn't work, then we freak out. Okay, so let's put this generated circle into our debug view, because that's the easiest thing to do right now. So here we'll just say circle source undefined, and then we need a solid color render. Oh, we have that thing, nice. So we can say solid color program is solid color program, and then we'll just kind of like assign after we generate this thing because it's easier to hook up that way. So somewhere we like create this widget eventually, and before we start doing anything, we'll say GUI debug widget. What is this? Hello? UI.debug widget. There we go. Circle source is generated circle. And then on render of this thing, can we fucking draw the circle? Self solid color render program render points, I guess, using our circle source. And we probably also want a transform to make it show up in the right spot. Okay. Color is white, I guess. All right. Oh, that's promising. That is freaking promising. Look at those fucking circle dots. Look at those freaking circle dots, baby. That is sick. Fucking awesome. Easy. So I think that's like pretty good proof that we can generate whatever the fuck we want now, right? So that's gen geometry. Dunzo. The next thing to do is try to generate this geometry with like a Zig SPIRV program, because again, all of the like work that we want to do, we've already written in Zig code. So like, I don't want to have to like port this over to like C-ish GLSL when I could just like compile the Zig and run that, right? That'd be super cool. So I don't really know. Zig SPIRV. I'm pretty sure this is like a thing that you can do. Pretty sure. Like, do we need a thing? Doesn't he just have like a SPIRV output? It's pretty new. I mean, I could have sworn that it's been in there for like forever. Zig language or like release notes. Like, is it not in 016? I feel like I've been seeing this shit for forever. SPIRV. Yeah, there's this, right? Zig also has varying levels of support for these platforms. I see. Well, let's just fucking rip it and just see what happens. I assume that we want SPIRV 32, right? Because I think that like GPUs like use it. Like I'm pretty sure that they're working in as 32-bit platforms usually. I think like a 64-bit GPU would be like incredibly rare, right? Am I crazy? Maybe I feel like the shader units are like usually 32. There's a blog post we get about some updates to it last week. New Zig can recognize SPIRV as object files now or something. Interesting. I'm just not gonna think about it, and I'm just gonna write like test SPIRV Zig. SPIRV Zig example maybe. Since we're in this vicinity, you can also probably draw metadata from shaders and use GL draw indirect. Interesting. Interesting. So you want to export a function as a kernel, it looks like. And that function, how do we like define our inputs and outputs? Does that blog post have like an example in it? Zig SPIRV blog post. Is that like recent? Boom, boom, boom. So this is new. Oh, sure. So they're kind of saying like before you couldn't represent, like probably the buffer was like a thing that you couldn't represent before, right? I wouldn't be shocked. Execution mode. So I assume that we're SPIRV task, right? This is what we're supposed to do. This does seem like kind of fucking sick. Like, this is worth pulling master for, right? Right, object file linking. Because I'm assuming that this stuff wasn't available before. So Zig nightly builds. And then I guess that this just has to be a separate project, right? Where, because we were using like different compilers, I don't think there's any reason that we have to use the same compiler for our normal stuff that we do to generate the SPIRV code. I think that there's no reason for that, so I think this is fine. I think this is fine. Fuck it. Fuck it. I think it is worth learning the latest and greatest. Yeah. So, because like, again, this just looks very important, right? But we'll see. I assume we're like a runtime array of like something that we want to specify like kind of hardcore. But I'm not sure. I don't know. We'll see. We'll see. So this test SPIRV guy, I guess we will just call him SPIRV test. Oopsies. What am I doing? Make dir SPIRV test. And we will unpack the latest and greatest zig here. Okay. And then we will make like I don't know, shader zig or something. And they're saying in this devlog that we should be, where was it? Where was it? Here. Like we're a task, right? So this is kind of our entry point here. Right? Cool. So we need to, like, are there fucking examples somewhere? Like, how do we like get our data? Here. This is their example, right? So they're saying, yeah. So this is going to be our data output. Address space is probably not constant, right? This is probably variable or something. We are trying to use some, like, I assume array would be my guess, right? Like, of, like here we specify a type. So elem probably, and then elem is a SPIRV type where it's like something. I don't know. We need to like look at like this definition of these things, right? So can we look for like sampled image in the standard library? Oh, here we go. Here is our example. So SPIRV type can be one of these. Image, sampler. Oh, so we're chill, right? We just have a F32. Or vec4, I guess. Right? I guess. It's probably something like this. Cool. So this is going to be our, v4 buff, I guess, is what we can call this. We're saying we have an output who is a v4 buff. Right? Okay. Where's this, like, constant definition, by the way? Address space. GPU address space. Global constant param shared local input output. It's gotta be output, right? It's gotta be output. Well, what did we call it in our version? What did we call it in ours? Fuck. What did we call it in ours? We called it buffer. Is buffer an available address space? Address space. Was it Langzig? Address space. Storage buffer, right? It's gotta be storage buffer. It's gotta be. It's gotta be. What is descriptor set 0 binding 0? I assume we're using binding, so I assume set just we take 0 is fine, and then binding we're setting 0 here. That seems kind of right. I don't fucking know, man. Where do I get this thing from? Where the fuck did I get this? SPIRV. This is unrelated to. Well, I wonder if we should take a step at like a C SPIRV first. Does that make more sense? Doing it in C first so that we can like figure out what the fuck this thing's supposed to look like at all without stacking on all of the zig problems on top? Oh, I'll see it. We'll do that if this doesn't work. Like, how the fuck does this work? SPIRV get global like OpenGL variable names. Are they just linked in? Like, can I just type this, do you think? Like it seems like it would have like it's just got like a name that you get linked in, maybe. Yeah, let's do this. Okay, as our stoop example, let's draw a line this time instead. Okay, we'll try this. And we'll say, like we just want our output at I. This is the name here is whatever the fuck we name it, which is like output, vert. Which we can just name output as well, right? Who fucking cares? This is the name for like OpenGL bindings. This is the name for use in our program, I guess. Okay. You could try to use it with 3JS shader language so that it would avoid a lot of compiling. Well, the problem here is that I want to use my existing Zig code eventually. So that's kind of why I'm doing this at all, is because I want to reuse all of the existing Zig code I've already written to actually do the like SVG stuff I've been working on. So can we just do like output I is like as F32 I, or I guess val over num segments, and then this is float from int probably. That seems kind of right. Like val f, we'll call it val f divide by num segments, and then we should get a line that kind of goes bottom to top if this is correct. That'd be kind of hype. Zig. Then how do we like build the shader? Build executable, right? Shader. He's gonna be mad, but we can just specify like target, right? There's some way to say like fucking build this shit for SPIRV. Target SPIRV v32 OpenGL. Use of undeclared identifier. Okay. There is something like stood SPIRV, I think. Yeah, so he doesn't like this. So good call. Global invocation ID. Ah, okay. Interesting. Okay. Global invocation ID. You're kind of saying do this shit. Undeclared identifier I. That's a really good point. SPIRV task requires the mesh shading ext feature. The fuck does that mean? I guess maybe this means that you have to compile the Zig compiler with special options. Or maybe I need to specifically ask something of this thing. Mesh shading ext. I see. So I need to specify features here. Mesh shading ext. Help. Feature. Mesh. Okay, well, that's not helpful. It's gotta be, you gotta be able to have to use LLVM. How? Okay, how does this, like, where do these come from? Features. Oh, I think that this depends on, the feature set comes from the target, usually. I think. Okay. So how do I determine, how do I get this thing set? I think you had the example from Andrew Kelly, right? Let's take a look over here. You're saying like in here he has some. How the fuck do I clone this thing? Here. You're saying in here you might have some examples. Let's take a little peek. SPIRV target, resolve target query. Yeah, so he's kind of saying like he's compiling for Vulkan, and maybe that changes something. Shaders. Here's his example. So he's using a fragment shader. So maybe we just can't do this yet? It's a possibility, right? Because the target should... Well, we can try some of the other targets. Right? We could try... Just see if it compiles, you know what I mean? So he's doing... If we do like SPIRV 32 Vulkan... Still no, 64. Oh, you're saying with FLVM. Oh, I see what you mean now. Yeah, that makes sense, huh? Core dumped, but that's a lot better than nothing. Interesting. Interesting. Maybe like the linker also needs to be set? Good shout though. I kind of see what you're getting at now. Is that a good sign? I mean, is it? I mean, it's better than nothing. Better than nothing. SPIRV target. So he's got compile zig shader is kind of the interesting piece here. I actually don't see the LLVM pieces in here. Interesting. Wait, what is this? What is the difference between these? Oh, frag config and vert config. Which he's just specifying from options. I see, because he got the fragment and the vertex shader in the same file. That makes sense. That makes sense. Okay. So he's probably doing something like if options... Yeah, he's like specifying the address space based off of the options. That makes sense. Yeah, I see. He is exporting... Oh, I see. He's exporting these things as main, which maybe we need to do. Right? Because, like, I mean, it does make sense that, like, it should be main. What do we call it? Shader zig. Like, is this main? Does that make more sense? Interesting. Does this like work? Is it like no. How did I get shader to show up there at all at some point? Like it was there at a point. I guess maybe before we started using SPIRV task. Okay, let's try to figure out how this mesh shading X'd is set. Or maybe do we give up? That's another option. That's another option is we just give up on this idea and port our shaders. Because maybe this just is like a not a thing that is supported yet. SPIRV compute shader. May 6th, 2026. That's pretty recent. What is this? I see. So this is using like some C library. No, I don't think this is what I want. I don't think that's what I want. You only code in Zig? I mean, usually, I mean, it's my go-to, but like, and at this point we have a lot of code built up in Zig, but you know, programming is programming. Programming is programming. Let the idiot port the code. Yeah, I mean, that's not crazy. Not crazy, except I just don't have all that shit set up on this account. But yeah, that's not crazy. I would have loved to get to the point where we could compare the whole thing. So like ideally getting this to work is nicer. Compute shader is not a task shader. Is it not? Am I a fucking stupid idiot? That's not that surprising to me. I think I just do you think it's a SPIRV kernel? Is that what kind of what you're saying? Is this bad boy? It is the same shape. You know, we might as well take a run at it. Hold. 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 Cannot assign to constant. Oh, maybe var here. Maybe like this. Woo! Okay. Well, that's not good. He's like, specify the C integer and float sizes for this OS is not a good, not a promising error, huh? We are so freaking back, baby. So we got stuck somewhere. I don't really remember where. We were trying to compile an example Zig SPIRV shader. Didn't work. We recompiled Zig from scratch, and we found somewhere in their target definitions, basically like the C mappings for their sizes, were not implemented correctly, or at all, I guess, right? As the panic we were seeing said. Somewhere we found a list of sizes here in the OpenGL spec. In reality, we didn't look at these at all. We just copy-pasted the definitions for the OpenCL and Vulkan, because we're like, probably the same. Probably the frickin' same. And now we have a OpenGL SPIRV kernel that compiles. Does it work? No fucking idea. But at least it compiles. So now we can try to load the thing and see if it does the thing that we expect it to do. That'd be kind of hype. That'd be kind of freaking cool. So I don't know. I don't really remember where we were, but it must have been somewhere around our SVG repo. We probably want to now somewhere where we use our compute shaders, I guess, in render debug, I guess. We had compute shader source, and I guess we just want to, wherever we use shader source here, replace this with some SPIRV thing. GL load SPIRV. I don't really know how this works. How the frick do you load SPIRV shaders? Those are GL uint, etc. CPU side tests, by the way. We want GPU side uint types in the GLSL spec. High chance of the same though. Good point. Good point. GL shader binary. Is that GL shader binary? Is that like in 4.6 core? Looks like it. Is SPIRV defined as one of the binary formats? No. It looks like the binary formats are completely undefined and are defined by extensions, right? So that kind of makes sense. So let's just assume that this is it without thinking. No thinking aloud. I assume SID here is the thing that they created the shader with, so this is our compute shader. And they're saying we have one binary that we are attaching to this thing, I guess, or one shader output. And this is the shader binary in memory here. So they're using this, and then here we need the shader. So this is going to be, I guess, can we like embed file for now? Just because I'm fucking lazy. Where is this thing? SPIRV test. Hello, ls. Is it this? Which shader SVG? Oh, not which. Sorry. File shader SPV. I assume that that's the output of this thing, but you never know. This is a SPIRV binary, so seems pretty promising. So we'll just kind of like rip this shit in here, and then we can do shader binary here and shader binary len here. Okay. Oh, and then this needs to be, I see why it doesn't like this because it's in source. So we are going to, for now, hack this and link SPIRV test shader here. Okay. Now this should at least compile. And do we expect this thing to run? Not necessarily, but it would be kind of cool. Shader compilation failed. Yeah, he doesn't like this. He doesn't like this. Which I guess is not incredibly shocking. Not incredibly shocking. What do we think he's mad about? Who fucking knows? That does not give me any useful information. Can we, like, usually, we were getting, like, nice error logs earlier. Because usually we see shader compilation failed with get shader info log, right? So this is supposed to tell us something useful. I guess we don't necessarily want to compile the shader. That's probably the problem, right? We probably want to do this instead. Like this. We are trying to check if this thing is equal to 1. But we actually want to do, like, if this is equal to 0, return error compilation failed. That seems kind of nice. Seems kind of nice. He is mad because I said SID somewhere, and it's like, no, that's compute shader, bitch. All right. Ooh, promising. What is not promising? Oh! Those are the freaking dots! Those are freaking dots! They're freaking dots! Okay, I know. It's not supposed to be that exciting, but the whole thing is stitched together. It's stitched together. That's freaking sick. Okay. Sick. So we do have proof of concept, compute shader, written in Zig, exporting useful information that we can then use to render somewhere. That is very nice. All right, we are so freaking back, baby. So to recap, yesterday we were working on trying to like optimize rendering of SVGs by parallelizing the like SVG path processing, right? So yesterday we took a break after basically generating a compute shader in Zig. So the compute on the GPU is done by code generated by the Zig compiler that generates, just points along a straight line, right? And the goal here was just to prove out the idea that we could use Zig code to generate geometry for processing on the GPU. And the idea here is that the way we process this SVG is for each scanline, for each contour, we check, we do the following, I guess, 2 steps. We check for intersections of a contour at the top and the bottom of a pixel, right? So like this blue is indicating that this is a exit of this contour from this scanline, and the pink is a entrance. Oh, hold on, this is a little loud. And so what we then do is we iterate these crosses in contour order, right? So we kind of walk all the way around this guy like this, and we pair up entrances and exits, right? And the idea here is that we're trying to prevent like edge cases in the world where maybe we come like in and then back out, This would be 2 crosses on the bottom, one going in and one going out. And so we would know not to count that as a contour crossing our pixel, right? Because it didn't make it all the way through. And the idea here is that anytime we go up or we cross down, like crossing the top and then the bottom in a consistent direction, we consider that a -1. And in the other direction is a +1, indicated by red and green in this visualization. And the idea here is that any time that the count going left to right is non-zero, we fill in, right? So what I want to do today is say we can do these steps very, very heavily parallelized on the GPU, right? So every single line can be processed at the same time, and every single contour can be processed at the same time. And so the first thing that we have to do today is try to figure out how to package this data for consumption by a GPU shader, which will have like one invocation per scanline per contour part, I think. Have you tested some other SVGs to make sure you're not specializing on the bundle logo? I don't really care that much about that, but yes, we have this one. I have one other one that I'm playing with, but I mean, there's a lot that we haven't done yet. But I'm more worried about the how do I say this? The renderer implementation than the SVG parsing, right? The renderer is this thing that lives after we've processed all the SVG data, and I'm pretty sure that once we get the bottom of the stack working correctly, adding all of the new features should be easy. But I want the thing that's doing the rendering to work right first. You know what I mean? Okay. So yeah, here is the plan. Here's the plan. We need to package some data for the GPU. And so I guess let's go, we need to go path by path. Maybe contour by contour. What do we do in our actual implementation here? We do render path to image. We have, calculate winding changes. So we work on a path level, and every path is built up of multiple individual contours. And so these individual contours, they track winding changes on their own first. So I think that then after we've walked all contours, we sort the winding changes by X position and then iterate them that way. So I think we want to generate winding changes per contour first. I believe that's the first step. So our first pass here, which is generating all of the cross points, I think we do for each contour 2 passes. Maybe is the play here. 1 to generate the crosses, then 1 to generate the winding changes, and then we do that for every contour on the GPU in parallel. Then we like process the final output per path on GPU. I think that makes sense. Okay, cool. So I guess that means that we need to, let's just do 1 contour first, because we're kind of doing everything in main just kind of here. So we want to, before we run our program, this program is being run once per contour. So let's get the contour that we think is most interesting, which I believe is the second path in the Blender one. Gives us like the biggest outline. And let's get contour 0, okay? We need to iterate over this contour. And for each value in the contour, what are we doing? We are like, okay, let's think for a second. So, our GPU kernel is going to have some data somewhere, right? He's going to have some data. And each thing that he's processing might be like a line, right? He might have a contour segment that's a line. He might have a Bezier curve that he's processing, or an arc, right? So I think what makes sense here, we need these things to stay in order that they are in the contour, because like that order is important to us. So we can either group by type and add like an index for where he should be output. Or maybe we have like 2 data buffers. Yeah. So we could have like, you know, line like start X, line start Y, line finish X, line finish Y, right? This is just like 4 floats packed together. And then we might have like a Bezier curve start X, Bezier curve start Y, and then times 4 for Beziers, because, or cubic Beziers, I should say, because there's like 4 parameters. I think that seems reasonable. And so like this data is just like raw, just a bunch of floats packed together. And then, so this is kind of like store, maybe we call this like storage, or like floats. F32 store, maybe, right? And then this gets passed in as 1 buffer. Then the second buffer will be like type plus index, right? So the first thing will be like, this will get like line 0. And then the second thing will be cubic Bezier 0, 1, 2, 3, 4. That seems reasonable. And then the kernel, depending on this type, will know how to interpret this data. He will know how many parameters he expects, and he will know how to like unpack them into like whatever structure he wants. I think that's reasonable. That seems reasonable. So I guess we have 2 buffers that we're outputting then, right? Let's do make buffers for contour compute. Let's call this. And oopsies, I guess we'll have or maybe it's like more like this. Contour compute buffers. And then it's like this guy's gonna have my brain. So we call this storage, float F32 store. And what was the other thing? I guess like item. I guess like meta process item, maybe. We'll just call this items. Fuck it. And I think that this needs to have like defined alignment and stuff, right? So we're kind of like say that's an extra instruct, just so that we know the rules of how that's padded. Arguably, this should pack the same no matter what architecture we're on, right? So it might make honestly more sense for this to be like viewed as a bucket of bytes that is interpreted differently. But for now, we'll just kind of rely on the zig packing, and maybe we will just assert that the offsets are what we expect, and then that'll be good enough for now. I think that's fair. Okay, so we are going to have size or offset where this thing starts. Arg start offset, I guess, is what this is, which I think usize makes sense. I guess maybe being a little bit explicit about this makes more sense, right? Having defined bit widths is better. And then what's the other thing? The other thing would be type. And I guess for padding purposes, like this thing is going to be aligned to 4 bytes. So it doesn't like we might as well just make this 4 bytes. This could be smaller or bigger, or this could be smaller, but I think like the effective size of this structure would end up the same no matter what size we pick here. So this is fine, I guess. Yeah, I think that's fine. And then let's just do like a comp time assert that offset of item arg start offs is equal to 0, and that type is 4. Right? Just to be sure. What's he mad about? What do you mean I'm not allowed to have... Oh, do I need to put this in a block or something? For that to think that... Yeah, there we go. Okay, and then let's just double check that if I were to set this to something wrong, that the assertion would fail. It would not unless we force this to be compiled, probably. Like this? This is how you do this? Perfect. Perfect. So now if I say this is for... We're chilling. Hype. Okay. Cool. So now let's just do something with this thing. So we say contour compute buffers, probably init, with the iterator. That seems reasonable. Sure. Compute buffers is this. And I guess technically, this thing, these are like temporary. Right? Like really what we want out of these is render like vertex buffer objects. But maybe we will kind of do those externally. I think that's fine. Okay. Pub function init. Let's take an allocator here. Like alloc std mem allocator, because we're gonna have to allocate these things. And contour is a contour, sure. Okay, so our output size, I guess we kind of know the upper bound of this thing, right? The maximum number of parameters, max params, is, I believe, an arc, which has 7 parameters, if I remember correctly. Line has 4 floats. This has 8 floats, because each point is 2. This has 6. And this has 1, 2, 3, 4, 5, 6, 7. So it's 8. Cubic Bezier is the most expensive with 8. So we can kind of pre-allocate. let's do an array list of F32, which is inits with capacity of, what was it, 8 times contour len. We'll just say maximum floats per item is 8 by cubic bezier. I think that makes sense. What are you generating geometry for? To parallelize SVG rendering, we want to generate the geometry for each scanline. Like if we have a contour, some contour like this, right? We are trying to generate all of the independent scanlines at once to draw like this, right? So this would be one set of geometry here. Then the next line we would generate this geometry. Then on the next line we would generate this geometry. That type of shit. I'm not sure. Thank you. I look like a child. Okay. Items. And then the amount of items that we're going to have here is contours that we want to process. So this is going to be, I guess, contour len. Cool. Cool. And so what the fuck are we doing? How far are you from implementing a web browser? Far as fuck. Far as fuck. I think that's one of those ones that we'll never do because, like, it's what I've learned from this stream a little bit is that specs are kind of boring. Right? So making an operating system seems fun until you realize that you just have to implement a bunch of drivers. And all of those drivers are like the same. It's like read a spec sheet, implement the spec sheet, check that what you did with the spec sheet matches reality, debug. And it's like, that is work, but it's not really like fun, right? And like the web browser is like the ultimate version of that, right? It's just a giant fucking spec full of edge cases that you have to implement correctly. There's a world where I generate like a HTML-like render engine that is not spec compliant. There's a world that we do that. Just as a fable, create a better Chrome browser, make no mistakes. Yeah, make no mistakes is crucial. Okay, so for each contour segment, we switch on that segment. And if it is a line, we can kind of just like ignore everything else for now, I guess, right? Like, we don't actually have to implement all of this yet. We can kind of only push the lines and push the rest later. I think that's fair. So here we will append. I guess we have L here. LA0. Okay, catch unreachable. LA1. B0, B1. And then we are appending items, append. So here, I guess we say that we are at offset. We start here first. What do we call this? It was like arg start offs is equal to F32 storage items len. Beautiful. And the type is 0 for line. Miss intro, are we still using Zig SPIRV shaders? Yes, that is the plan. To sidestep the boredom of endless features, but still satisfy the completionist me, I sometimes apply the rule like I will implement the state of the art as of 1998. Yeah, that's not a bad idea. Not a terrible idea. I guess we need to catch unreachable here too. Okay, so now we should be able to say, for each contour, I guess we are literally looking at the first contour. So we're like, just fucking rip that shit. And I guess we are putting this all on a scratch buffer. Right? Where we are maybe trying to return the F32 storage buffer and the items And now we can kind of say we have a checkpoint, which is allocators scratch checkpoint, defer, allocators scratch restore, because we don't need this CPU memory after we've moved to the GPU, which means that we should be able to just at this point, like create two buffers. So I think we have like stud render shader program buffer, which we can just feed with data. Beautiful. Do we need to specify the type here? Yeah, so this is going to be F32, which comes from compute buffers, F32 storage, okay. And then the other one was contour compute buffers item, like this. And I think these need to be attached to some OpenGL allocator. Okay. Beautiful. I guess this is a reused name, is why he's mad, probably. What's he pissed about here? What the fuck is he mad about? Oh, I'm missing the allocator's scratch. All right. So now we need to use these things. So we are going to say, we are going to bind buffer 0 like this. And buffer 1 and the items buffer at index 1. Cool. Which means that in our compute shader, where the fuck that is, test. Where is that? SPIRV test shader. Here we need to define two inputs now. So here we have output. We need two inputs. We're gonna call this items. So this guy, each item is, what do we say? It was like arg-offs U32, we said, and then arg type U32, right? And then we should do the same assertions here to prove that we have the same like structure layout, I guess. Cool. And then we are going to have, I guess we will call this buffer thing that we had before. This is output buffer. That is a nicer thing to say. And then we will call this thing a float array. That's an, or an F32 array maybe is a nicer thing to call this. And so our item buffer is a extern struct that has data F32 array. Right? This is the same. No. This is an item array. So we need to define item array, which I hope works. I don't know if this is valid, but we should. Okay, can we just feed item here? Does that work? I don't know. Okay. Oh, so we need our output buffer too, which we completely forgot. Okay. So output is now binding to, this is items, which we had bound as 1. And then this thing is item buffer here. Okay, and then we have F32 storage, which is F32 storage, like this. And so we need this thing to be a struct as well. F32 storage is just a thing that holds an F32 array. So maybe we can call output buffer, this is like F32 buffer instead, and then we can use the same type here and here. That might compile. I don't really know. Let's go find out. That's good news. Okay, so now what are we trying to do? We are trying to look at, for each time we execute this thing, we are looking at items val. We'll put a fix me here, set upper bound. We need some way to set like a uniform probably to limit this, but for now we'll just do this. And we will say, ideally right now what we do is we just draw points at our scan line. So we need to know our scan line, by the way. So this has got to be our y value here, right? I guess we need to know the like input width and height. But for now, let's just assume yeah, I'm not sure. Yeah, well for now, let's just generate the geometry of the lines themselves so we can prove to ourselves that we understand the input data. I think that's the play. Ignore the scanline stuff for now. So we just kind of want to say like output data val. Oh, this is interesting. So the output here, we need to know how many outputs we can expect from this thing, right? So for a given scan line, we can expect one cross, right? At the maximum. For a cubic Bezier, I guess theoretically you can have something like this. So the maximum crosses per segment is going to be 3. But we know the maximum crosses for our segment by the type. So maybe our item should have like output offset. You know what I mean? And we kind of determine what that is based off of the index and how many we've consumed or something like that. Yeah, that seems reasonable. Oh, so here we can say out offs is 8. Okay. Cool. That seems reasonable. So here we're like output data at item, I guess we'll say this is our item. Item out offs is going to be the first. I guess we'll just say that we'll take the start of the line for now as our like test here. That seems reasonable. So this is going to be like line. Or I guess we're going to look at item dot arg type. And if it's 0, we are going to do something. Else we are going to do nothing. That seems reasonable. So if it's 0, this is line, right? We could fix me named type, but this is line, right? Fine by me. You can probably work out the number of crossings by looking at the y-coordinate of the various control points. Yeah, but that's going to be different per scan line. And I want to rip the whole scan line. I want to rip all scan lines at once, was the idea. But you're right, there is some sort of like early bounding box intersection test that you can do that would have sped this up. But on GPU, I don't know if it's worth doing. You know what I mean? On CPU, it is. On GPU, I'm not sure. Okay, so this guy's going to be Ida, like, I guess we need to get the line. I guess we're gonna have params here as a slice of F32. I don't know how well this, like, the address spaces work here. Right, but I would love to be able to do something. I guess we don't have to find the type, and then the address spaces don't matter. And then here we should be able to say, like, what is our thing called? F32 storage. Which is binding index 0, by the way. So I want to say, like, F32 storage data from item arg offset 0 to 4, right? This is what we're expecting. And so this is going to be like param 0, 0 and param 0, 1 is what we're going to use for, we're just going to like put a point at the start of the line. For this, I would assume everything in global segment, local memory shouldn't be necessary. I agree. I don't think we have any local memory yet. That's my understanding. Maybe I'm doing something stupid, but I think that makes sense. So I think that this seems right. This should draw us a point at the start of each line contour if we did all this right, which we probably didn't. Okay. Items val does not support indexing, right? Because this is items.data. Because it needs to be a structure. So we have like a little, okay, cool. Slice of non-array type. Yeah, this should be F32 array. Yeah, I don't know what the fuck I'm thinking. V4 array and F32 array are different. Okay, so somewhere the output is a V4 array and the input storage is a F32 buffer. Oopsies. V4 buffer, because it needs to be like this. All right, does that work better? Slice of non-array type. SPIRV runtime are interesting. So SPIRV arrays can only be indexed by individual element, maybe? That's interesting. So this is gonna be like line start X, line start Y, and we have to use those like this, maybe? Is this what they want? Okay, that compiles. Seems good. Damn, is Zig SPIRV backend functional now? We did have to patch it to get it to compile at all for our OpenGL target. But we'll see, right? We're not making any promises. We're not making promises. Okay, so this builds. That's promising. And so then can we run this thing as a whole? He's gonna be mad because whatever the fuck. Let's just rip compilers. Yeah, this thing can't fail. True. And then we also needed to add the arg and offset. We didn't have that part, right? Out offs. Yeah, I guess we'll do this. And then what are we doing here? I guess it's like when we are generating these compute buffers, we need to have, I think we just like say out index is 0 here, and then we increment this depending on the type, right? So we know that like lines are supposed to output 2 or 1 point at maximum. You know what I mean? So what do we call item? Out index is out index. And then we say out index plus equals 1. Because there's maximum 1 cross per line. Seems reasonable to me. Int cast here. I guess here we will also say like U32, because like then we don't have to int cast. Cool. We do have to return the thing. And items is items. Okay. Cool. So what's this guy mad about now? Probably have to try. Okay. We compile. Let's see what happens when we run it. I see some points there. I do see something. Are they kind of, do we just have 1 point? Not looking promising, right? I guess what's probably happening here is a lot of the points are, no, every point should have an output. So it does seem a little bit concerning here, right? Where no matter how much we zoom, they all seem to be rendering at 0, 0. But we're probably not queuing the right amount of work items. Right? So here we should be dispatching compute based off of items len, I guess. Okay, still looking not good. Now maybe we're doing something wrong here, right? So can we, how can we prove anything here? How can we prove anything? Let's just start with like binding check, right? So maybe you just do data. Um, thinking? Thinking? Let's do what we did before, which was val f here. Which is what? Oh, I guess our output size is probably wrong as well, actually, now that I think about it. Right, this buffer needs to be determined by the output len. You know what I mean? Like something like this. And this is gonna be this is, I think it's outline here. Okay, that should help us a little bit. Compute buffers need to write this thing down. Okay. Cool. I think the SPIRV kernel thing might be a problem. Index size of one, like size of one. I think grid size of one seems fine for what I'm trying to do. I think. I could be wrong. Okay. Now, let's try to prove to ourselves that we have this. So we want val f is an f32 float from int of val, and then we say val divide. I guess we just kind of use the index directly. That seems fine to me. Like, we're just hoping to see some sort of movement in this shit. Okay. Either... Yeah, not promising. Not promising. Okay. What if... Wait, did I compile this? I think I might have forgot. Okay, we need to like make a build command that makes sense. We need to make it so that when we zig build in this thing, like our project, that we build the actual SPIRV module as well, or else I'll forget a lot. But for now, I don't know. That seems like work. So instead, I'll just eat the punishment. There we go. Yeah, I'm not seeing anything interesting here. Nothing interesting. Should not be a correctness problem because we specify in GLD special compute. That's my understanding as well. Okay, so we could have easily bound wrong, right? So let's just like triple check everything. So item buffer is data f floating point buffer is a floating point array, which is a runtime array of f32s. That is bounded 0. This is not being used right now. Shouldn't fucking matter, right? V for the output is at binding 2. So we should bind 2 to the output, where we are expecting a v4 buffer, which is a struct that has a v4 array, where the v4 array is a vector 4 of f32. That seems right. In main, we check our invocation ID, and we just plop that shit in there. Can we like read the data manually instead of looking at it visually and see if that gives us any information? So what was it? Is like GL read buffer? No. I forget. We did this yesterday. I just forget. Open GL read data from buffer. He's just wasting 63 to 64 threads per warp, I'm pretty sure. Is the warp definition by, like, I was, like, do you need to use, how do I say this? I was under the impression that the dispatching would be smarter than that. That was my understanding. Like, I would think that but are you saying that it's like XYZ is like one of those is warp dimension and one of those is GPUs are dumb as fuck? But like the GPU driver could do something smarter. GLs get buffer subdata. Work is always especially the warp level, so it makes sense to have a block size with multiple work size. Yeah, but like from OpenCL, it seemed like this XYZ stuff, like the thread group that it dispatched to, like you could do one-dimensional work. That was my understanding. I can double check that at the end. For now, I'm not like super concerned about it. I thought that the XYZ thing was like kind of just like an optimized, like a hint, but nothing more. But I could be wrong. I could easily be wrong. Was it GL get buffer subdata? Like, am I even fucking running this shit anymore? Buffer buff offset 0. Size out len times 4 times 4 void data read back is maybe something like this. We're like trying to read out len times 4. I guess you can actually just read like a vector for f32 like this. Something like this. Maybe we'll read it back unpacked to okay, for read back for I guess like 0 to outlen, we do like debug print like the slice of read back I times 4 onwards from 0 to 4 or something like that. The fuck? Oh, because, okay, so he's getting, oh, that's interesting. Is outlen 0? Is that the problem? Am I an idiot? It is 0. That's concerning. Oh, because the first contour is empty. We have a bug where the first contour is empty. I see. I see. First contour 1. Aha, that's much better. Well, it's better to some degree. The output length is defined, but the values are clearly fucked, right? Pretty clearly. Okay. I'm sure only one pixel is being processed because you only gave it one thread. Did I? GL dispatch compute. No, this seems to be right. Oh, this is by inputs though, which is kind of interesting. I think that's right. We should be doing inputs, our input length. Can we just like do a quick little double check? Num items is this. Yeah, these are tied together. So this should be running the shader, right? And so it could be that the output offsets are wrong. So can we here just output to val to kind of try to reduce number of places where we could be fucking up? Okay, that's not doing shit. So it looks to me like the output is just not getting written for some fucking reason. For some fucking reason. But why? But why? Am I wrong about like GL bind buffer base? Like, am I wrong about what the indexes are here? We're saying specify the index of the binding point within the array specified by target. Binding point within the array. Much earlier used 2 for the second element of the SVG. I think that's fine, right? Because right now we're not even using the SVG data, right? Like we have something that says there should be 13 points in this thing, and our shader here is just writing out literally like the index directly. He's not even touching the data, so it shouldn't matter, right? So it seems more like this stuff isn't behaving as I expect. I'm just gonna quickly unbind this stuff and go back to only binding the output. And saying this is binding 0. And then commenting this stuff out for a second. Just for a second to see if that's related. Right, he's mad because this stuff is dead. Interesting. Still totally fucked. Which was, this is confusing because this was working yesterday. It was working yesterday, which is making me confused. Making me confused. Is it possible that like this memory barrier needs more? I don't think so. Yeah, I'm missing. I don't know what I'm missing. Well, we can like git stash everything to compare, right? Because this is what we had yesterday, right? So this was working, right? We had some stuff written out. And so can we maybe... Oh, that's actually interesting. The SPIRV test stuff was not in there. So the... Luckily... how do I say this? how to say this? The SPIRV thing that we have right now is like good. The shader side. It's got to be a setup problem. It's got to be a setup problem. So what have we changed? What have we even changed here? We like create the buffer somewhere different, and we could create it with a different number of elements. But like overall, I don't really see a major difference. The fuck? Oh wait, no, it's working now. Oh, interesting. Interesting. So what we see here is that the points are rendered as we expect, but the read back data is garbage. So it must be a timing problem here, right? Where like maybe if we do this like do we need to like GL get buffer sub data memory barrier? Like, are we missing something? Are we missing like a flush or something? Have we seen that in the past? Are we reading back the right amount of stuff? We're reading from buffer after dispatch compute, after the memory barrier. Yeah, seems fine to me. We already looked at this though. Command data sourced from buffer objects by draw and direct. Can we ask the idiot? If I generate data with a compute shader, then read in OpenGL, then read it back with GL get buffer sub data, how do I make sure the compute is finished and the data is ready to be read? So like a client side thing? Yeah, maybe. Synchronization point. Simpler alternative. Buffer update barrier bit. Can try that. Oh, GL finish also sounds familiar. Yeah, what the fuck? That's so strange. Am I calling GL buffer get buffer subdata correctly? Oh no, I'm not. I'm an idiot. This is like this. Ah, I was just calling the function wrong. God damn it. Yeah, okay. Idiot. Idiot. What? Silly me assuming that they were using IDs. Silly me. Okay, sick. Now we can go back. First of all, SPIRV test. Let's just add that so that when we eventually start rolling back, we don't lose it. Okay. Let's bring items back now. And try to write to items out, whatever the fuck. Items val. What is it? It's out offs. And this should be the same thing, but we have to build it first. Which he doesn't like. Okay. Okay, so bad news, data's all zeroed when we make that change. But that's because we didn't actually bind the data. Like idiots. Okay. There, okay, that seems to be working. Cool. And so then, can we bring back the floating point storage stuff as well? Oh, well, first let's move the output buffer to index 2, like so that everything behaves so that we can add in the input data where we expect it. So output binding 2, if we go into, SPIRV, build this, go back, build this, that's still working as expected. Great. So now we can bring in F32 storage, which is at 0. Bring back this stuff. All right. So this is promising to some extent, right? All of the things look like homogeneous coordinates. However, they do not look sane in any way, right? It seems like all of the floating point data that we are indexing is 0. So that's not good. Because we didn't bind the data. You do have to bind the data if you want to use the data, if you think about it. Woo! All right. So now, hopefully, we see something that resembles something, right? These are only the points that are, like, the start points of lines. And they don't even overlay nicely with this. But, like, we should be expect to see, like, maybe here, like a horizontal line here, then like something up kind of like diagonally up from that, a horizontal line with a diagonal down or something like that. Horizontal here, maybe horizontal here with a diagonal up, maybe, and then like the start of the top of the, this thing. It does look like, what's that little cluster? This up here is like the actual thing that we're trying to render. And then this is like we're applying, we're like double transforming something somewhere. I think this is right. I think it's right. So now what I want to do is I want to actually calculate the y-intercept for each line. So what I want to do here is I want the dispatch compute. Here we want like to use the output height to calculate scanline intersections, right? So our like output size is going to be max number crosses per line times vector size bytes times number times output height, I guess. So this is the like buff size bytes. So we're gonna do byte size elms, I guess, first, which is gonna be max number of crosses per line times num scan lines or something, right? Then we have buff size bytes is buff size elms times 4 times 4. This gets used here. Maybe times 4 here, because we're kind of working in floats F32s. Okay. And then we want to dispatch this such that, okay, read back here, I guess, is buff size elms. This is buff size bytes. Okay. Then we are looking for max num crosses per line. Is this true? No, this is just outline. This is just outline. Num scan lines. Let's do like 100 for now. We'll figure out how to like tie this to the input size later. And then I want to use num scan lines as the y parameter here. And so far that should just work, right? Right, okay. But what I want to do now is I want to change the shader to calculate the y-intercept of these things. So we have the code for this somewhere. And I guess we want to copy paste it. Okay. So copy all of this down here. And it's this guy gets the cross. And we're just going to take the position as, I guess, X position, Y position, probably. We're going to use Y here. Line needs to be defined. So we're going to say, like, line is a line. And we need to specify A and B. Right, so first we need to, like, to convert, I guess. Okay. Then we can call this function, which doesn't exist yet. And then we just copy paste these guys. So line X for Y goes here. We need the line definition. Which we'll just copy paste like this. You need the point 2 definition, which is just a vector 2f32 or something. Ignore this for now. I think this is fine. Now we just need to specify Y. Global invocation ID 1. Okay. And then we need slope positive as well. Now, eventually, it would be ideal if we could, not copy paste everything. But that's a problem for later. Where's cross defined? Math.zig cross 2. Vector, I guess let's define vec2. Okay. How are we looking? I guess we don't care about if the slope is positive yet. That's a problem for later. Okay, let's try to build this. I'm sure this is gonna freak the fuck out. Expected F32 found U32, so true. Let's use. Reached unreachable code at generating a mem swap. Uh-oh. I wonder if it's like some bullshit, like these things don't have like real addresses. So calling mem swap to sort is a problem. So can we do something like call min A and B instead? And call max here, like this, and then not do the swap here. I suspect it's like some bullshit like that. Okay. Let's say that we have yu and yf is a float from int yu. Maybe we just call this y. And he's like, I expected integer type because I did convert him already, so true. We cannot export an optional yet in SPIRV. So there's a lot of things that aren't implemented, I guess. So let's, I guess, like, Can we replace this with a bool as the last parameter, maybe? And then here, this is undefined, not false instead. Maybe, and then this is true here, and then we can't do if line x for y here, but we can do valid, like this, maybe. And then we say if not valid, return. I don't know what we're doing here if it's not valid yet, but it seems like I guess it's like if valid. This kind of represents what we were doing in the other version of this thing. Okay, 86 is mad. Yeah, so let's say invalid. We can define this here as undefined, false, and then hopefully that coerces here and here. Nice. Nice! Okay. Let's just run it and see what happens. The number of items that is being generated is like fully wrong here, right? 13, outline of 13. I guess it's 13 per line. Can we double check what we are dispatching here? So we're always outputting to the same scan line, I bet, in the shader. Right, our output index needs to be multiplied by our y. We need like something like outputs per line needs to be passed into this somehow. So I would love to have like a uniform here that's like outputs per line. I don't know how to do uniforms yet. Is there a reason to parallelize SVG rendering outside of it being nerdy and fun? I think that if we want to do like multi-sampling anti-aliasing at high resolutions, like what we've implemented is not fast enough. Now that doesn't mean that like this is the only way, but I want to see if this is like a reasonable approach. It'd be kind of cool if it worked. You know what I mean? How the fuck do you do uniforms? Like, are there any examples of like shaders in this thing? Test, cases, shader, SPIRV, call convention, image sampling. He must have a uniform in here, right? UVN, color out, outer space constant. Right, like this seems kind of relevant. Right? Like, because usually images are bound that way. What options do we have for outer space, I guess? Constant sounds kind of right. Oh, also interesting that our address spaces do not have input and output. Oh, but that's because we're using shader buffers, which are not the same. Also, what is like descriptor set here? That seems unclear to me. That seems unclear to me. But I guess we will see. Okay, so let's try. Wait, I already forgot. I already forgot. I already forgot. Source. No, test. Case. SPIRV. extern pointer to an outer space constant SPIRV type. So here we want like LMs per, like our outputs per line. We want an extern pointer to a constant outer space, like U32. You know what I mean? And like we can just say descriptor binding 3. I don't know what descriptor sets are. That's kind of confusing. But I would like to see... Am I forgetting something? Okay, that seems right. Maybe the descriptor set is like, am I a uniform or am I something else? I don't know. And then on these other guys, is he specifying outer space for, or like descriptor set for these? No. I want to know what this is. I want to know what this is. So can we look at like the standard library? We're looking for like binding. Are we in the wrong folder for this? Yeah. Binding. What about descriptor? Decoration descriptors, set binding. No real useful things here. In Vulkan, descriptor set is like a group of bindings. Each set can have multiple bindings in it, and the order of sets matters because rebinding a set unbinds all sets with higher index. I see. But in OpenGL, I think that we're probably set at 0. That seems reasonable. I'd be willing to, you know, allow that. So it sounds to me like we should be able to maybe do like a uniform bind here. So to test, we can make all of our outputs go we can say use float from int outputs per line here, just to like see if we can control that variable. I think makes sense. And then in here, can we go like GL bind uniform, or was GL uniform? We want like one unsigned integer, right? Which is location and value. So here we think it should be location 3 with value of like 100. I guess we should compile our shader. They're all showing 0 as a bad sign, right? Seems bad. I think it's likely that we're like in a different space. Can I like query uniforms OpenGL program? Is that like a thing that I can do? Get active uniform. This isn't really what I want. I don't know if that's really what I want. There is a thing to get uniform based off name. Yeah, I guess we have tried to name this thing, right? Did we try to name this thing sanely? We called it outputs per line. Can we look at like the address spaces maybe? Right, there's like an address space definition. Okay, global constant param share input local uniform. It's just, we just have to set, this thing surely has to be uniform, right? Okay, and then if it's in the uniform space, then like binding 0 makes more sense, right? So can we then in the guy, can we bind this thing to 0 now? Oh, we see some 100s there. That's a really good sign. Really good sign. Will we set this to 200 now? We see some 200s. Mwah! Beautiful. Beautiful. Okay, so now we can set that according. I like how you were too lazy to set up shader compilation and build it and have spent more time manually compiling them since then. Yeah, this is the classic. I know. Outland. So we should be able to define this now as like outputs per line times y plus this. Right? I think that this is what we're looking for. I guess we have to fucking build this thing. Outputs per line dot star, I guess. All right. So now what we want to see is, I guess we need to collect way more than 13 outputs, right? So this needs to be times num scan lines, which do seem to have some amount of things in here, right? The vast majority are empty, but that's okay. We'll flag those later. Christoph, thank you for the prime. Much appreciated. So are we correctly like using that? Like, how do we know the length of this thing? Like, when we create our vertex array object, we are kind of just using the buffer and saying, here's your stride. Nowhere do we, oh, len is set here. So here we want to set the len to out len times num scan lines. And then when we render this thing, oh, those are some fucking lines, baby. So that looks like we are iterating line by line and adding a point for each point where we cross the scan, That's pretty fucking sick. That is pretty freaking sick. Cool. So I guess, can we put the slope as the z value here for now? I think that's, the easiest thing to do here. I guess, like, if slope positive 1 else 0. This is a stupid way to represent this, but that's okay. So do we see in here any z parameters of 1? I guess we will probably see them. Can we? I think it would be nice to flag these. I think let's change the format of the output data. I think it's probably time. Right? How do we want to represent this stuff? It would be nice to continue. I would like to keep the format in a way where we can see it. How do I say this? I would like to keep the format in a way that we can visualize all of the points so that it's clear when we implement like the rest of the types that it's correct. However, the way that we're representing right now is stupid. So I would like to have an output format. So can we have like output? And this is going to have maybe x, y. I think that makes sense still. The y might be implicit. Y should probably be a U32. Y might be implicit. So maybe that'll be removed, but we'll leave it in here for now. We'll have a Boolean to say if the slope is positive, which I guess because this is crossing like a memory boundary, U32 is like more obvious what we should expect this thing to look like. Okay, and so now we're gonna have this thing as our output array, which is a bunch of output. And then our output buffer is a holder of output array, and then the v4 buffer here is output buffer now, which means on the other side, we need to define an equivalent structure. Okay. Okay, so we defined this somewhere. This is going to be buff size is this times num scanlines times size of output. Nice. No. Just like this. Then this is size of output here. Cool. Then when we read this stuff back, we are using an output here. When we read it back. And when we set up our vertex array object, I guess we were going for each item now in read back. I wanted to say valid or not. That was the other thing I wanted in this thing. I want to be able to say like if like not valid, you know what I mean? Like return or like continue, so we don't print all of them. That was kind of my dream. Okay. So output needs a valid, and then figure out better packing, right? Obviously, like this can be U16 at least, which I think makes a fair amount of sense. That like I have in my head as a layout that I understand. Okay, so positive U16, valid U16, right? And we're gonna say else output data valid is false or 0. Yes. And then here we're like, fuck, where am I? Where am I? X equals X, Y is Y, positive is this, and then valid is 1. Okay, that seems right. Yeah, we did just lose the dir function, huh? We did just lose that. Normalize length. Length 2. We need all our math functions. There we go. Isn't the whole point of running shaders in Zig to be able to share tests between CPU and GPU? What's the point if you still have to copy paste structs? I'm not going to copy paste them like long term. I'm just doing this now because it unblocks like having to be able to compile all of the stuff, right? This is like experimentation land. I'm just copy pasting. Copy pasting is still easier than rewriting. But later, if this goes through and works, then I will work on having a set of code that is compilable with both Zig versions and imported correctly. I just don't want to deal with all that shit. You know what I mean? Because you're right, that is the goal. That is the benefit. I agree. Because like right now, like for example, right, this line x for y function, right? This used to return an optional struct, right? Like this. And then the SPIRV backend was like, I don't know how to fucking compile that. So I can just hack this now and then deal with like the fallout later. You know what I mean? You know what I mean? Okay. Did I do everything I need to do? If valid is equal to 0 is what we want to do here. Okay, does this work? That is looking promising here, right? Everything is getting flagged as valid, and all of the valid ones are looking good. However, I think that our vertex bindings were now probably wrong here, because we want to say we are packing 2 floats at, and the stride of this thing is now set wrong. Stride of this thing is size of output. Then I think everything else kind of just works. Yeah, there we go. All these lines are still here. Yeah, Zig language constructs are not going to play with SPIRV. Makes sense. Makes sense. Okay. So now that we have that, I think that we're in a good spot to start implementing like more of the curves. I think. Bedtime. Nighty night. Nighty night. GL Sphero. Yeah, we are working in OpenGL. Also, good luck. Okay. So let's start copy pasting some of the cubic Bezier solution stuff and see just how like turbo fucked it gets. Let's see. Shader zig. I guess the cubic stuff was in renderer. So somewhere we said, if we see cubic Bezier, do this. So I guess the first thing we have to do is actually pass that data along, right? Because we haven't done that yet. So if we see cubic Bezier, we need to pack this data, right? So we're going to go, this item is of type 2. His out index is out index. I believe that out index gets incremented by 3 here, because a cubic Bezier can cross a scan line 3 times because it's a cubic. Our start offset being the floating point storage makes sense. Type 2, out index, out index. Okay, so now we just have to pack in, I think it's 8 values here, right? It was CB start 0, 1, then it's going to be control point 1, then control point 2, and then the end. Okay, cool. Cool. Which means now we go back to the other side? I don't fucking know, man. And if we see 2, then we are a cubic Bezier. I guess we should also probably try to set the... I guess it doesn't matter. Okay. So if we see type 2, we need to pull back out the cubic Bezier. Probably. But I guess let's start by copy pasting what was in here, and then it'll become pretty apparent what we need to fix. So we need a cubic Bezier C. Case Y is now just Y. Right, we got rid of that concept. And let's do this. So this is going to be a cubic Bezier, which we should share, but for now we will not. And I guess that means that in renderer we have a definition of a cubic Bezier that we can copy paste here. And I guess let's just start filling that shit in. Point is vec2 in this land. Okay. So start is going to be this. Start. Control point 1 is 1 and 2, or 2 and 3. Control point 2 is 3 and 4, or sorry, 4 and 5. And then end is 6 and 7. 6, 7. You guys know when you're like children and you like saying 6, 7? Shut the fuck up. Okay, Bezier, T for Y. We'll copy paste the. Oh, fuck me. This is a lot of code. This is a lot of code, but that's okay. We will get there. Okay, so we need to copy paste our entire cubic solver, which is going to be fun. So that's going to be in, let's see. Okay, solve cubic here. Math zig. Solve cubic. It's kind of like all of the stuff from here down to here. I'm sure that this won't compile. But we gotta start somewhere. So let's, for now, just kind of ignore all of this and just see, like, how bad is it? Great. Solution anon. So he's saying that we probably, the cubic solution, it seems like, is probably what he's mad at, right? We saw something, I saw the word solution in here. Right, so we can probably assume that this cubic solution, which returns a structure that has a buffer inside, is probably a no-go. Is this part of the Wayland compositor? Kind of. Kind of. Because, how do I say that? We need to render icons in the taskbar, and the icons are SVGs, and we want to render the SVGs good. I want to render them fast. So this is related. This is related. Okay. So let's also write down like zig bugs we found, or like unimplemented, I should say. Optional return, and now we think cubic solution. Okay. So I would love to kind of scope this problem a little bit, right? So let's try, instead of trying to solve the cubic, can we just call the code for like solve cubic, one of the subcomponents of this thing. And let's just use maybe, you know, a couple values from this thing that are like runtime provided. Just to make sure that this gets compiled the way I want it to. So maybe something like this. And I'm assuming that this won't compile either. Yeah. Okay. So I'm going to assume that if we go in here and we change the format of this return, that this will work better. So let's make it so this cubic solution, instead of being a 3-length buffer, is A, B, C, right? Like, we'll explicitly mark these. And then this guy can say, sorry, I'm just trying to think of how to do this. Return A is this, but with a 0. B is with a 1. C is with a 2. Len is 3. I suspect that this will help us dodge the problem. Okay. Then for 0 to t's len, this is an index. T is switch on the index, and if it's 0, we get a B, C, right? Just a little tricky. Floating point width of 64 bits is not supported for the current SPIRV feature set. Where is that being used? Probably in some standard library function. Unless I typed F64 somewhere. No, this should be all F32s. Yeah, it's probably like rational prox binary 32, right? So probably if we start going in here, it's in the implementation of cosine of ACOS. So he's mad because we use F64 in here, and he's saying, what is the error again? Floating point width of 64 bits is not supported for the current SPIRV feature set. Yeah, okay, so that's like a pretty big blocker. Or, how do I say this? We fix this, right? That's one option. Might be fucking hard. You might just need to compile to a newer SPIRV target. Oh, because of the feature set? Yeah, I guess that's possible. Can we look at like what that error means in the Zig codebase? I guess that's probably the play, right? Floating point width of 60. Here we go. So supported comes from target CPU has float 64. Okay. Float 64. So we're looking for somewhere where they're maybe looking at SPIRV. Dependencies feature v1. So how? Right, that's all this means, is that we just need to compile for SPIRV 1.0. You assume I'm just targeting the wrong thing. Yeah, it does kind of seem like that, right? Enable float 64 capability. So I probably need to specifically flag this, right? How do these features get enabled? Right, like this is going to be related to, like somewhere they're gonna map the like target string of SPIRV 32 OpenGL, right? Like that's gonna get mapped somewhere. And I don't know how to find that mapping. Oh, here. Right, it's gotta be this, right? Is that this feature set doesn't have version 1.0? Right, because we're compiling for generic because the OpenGL model doesn't exist yet. Just use the Vulkan one. Can I? But I don't think I can import the Vulkan shader as an OpenGL SPIRV, can I? I kind of assumed that wasn't possible. Really, I assumed if you're compiling for Vulkan, you have to be loading it with Vulkan. Because like all of the like global types that are referenced, I would think would be like defined by the spec that is being used. But I guess maybe it's like the other way. Maybe SPIRV defines some imports that both OpenGL feed in. Yeah, maybe. Can you just add the v1.0 feature in build Zig? Yeah, can I? Well, I'm not running a build.zig right now. You think that if I don't use the Vulkan features, it might be fine? Yeah, there's a chance. There's a chance. I agree. I'm just running build exe directly. Can I add features this way? Feature. Yeah, maybe we just make a build.zig here. And we try to do something here. Not in general, but the Zig implementation might not use much of the Vulkan SPIRV yet. Yeah, that's a good point. You're right, the feature set did look fucked. But I assumed that there was going to be like, or like low. I just assumed that there was going to be like something more interesting later on. But I am down to try. So this is like Vulkan here, I think we just say. Oh, interesting. It's still broken. Even if I compile for Vulkan. Maybe if I do SPIRV 64? Even that doesn't seem to work. Interesting. Interesting. Okay. Going back and looking again. What are the possible targets? Yeah, Zig, build, or... Sorry, hold on. We need this. Build, exe, help. Hello? I found it here, there we go. Is there like a list targets? Maybe unlucky. I think you can add features with building using MCPU. Seems likely, I just don't know how to do it. Is there like a way to list targets? Targets. Nice. Okay. Yeah, so this is the definition of SPIRV with all of the features that it might have. And then how does OpenGL factor into this thing? OpenGL is just an operating system. So what are these like? Hold? Maybe there's another piece of the target string that I'm missing, right? There's like... Right, there's Arch, sub, OS API. So sub is probably what we're looking for, right? Like the feature set fuck. Right? Like this looks like a thing called sub, right? So if I run compile with like generic, like SPIRV 32, and then write generic here, maybe with a dash, maybe without a dash. I think that that's how we select one of these models. Nope. Maybe it's the MCPU flag? Aha! Vulkan V1, 2 or something, right? It was like something like this? Huh. Does this have to come before? I thought we fucking had it. Does this even like sanity check? Yeah, okay, so these are my options. Interesting. Interesting, right? So now it kind of looks like you think that I should be able to do like MCPU plus something? There's this. Let's see where you're taking me. Yeah, I see. So you're saying add float 64. So you're saying you think that I can do like something like this? Yeah, I can kind of see what you're saying, but like maybe we just use a build.zig and do it there. Right? Maybe. Okay. Yeah, let's just do this. We'll just copy paste this thing. Hello? Oh, I'm in the wrong folder, that's why. Okay. So we are only compiling a executable like this. Name is shader, I guess. Shader. This is just shader zig here. We don't really care about the target option because we're manually resolving it. And we're kind of hoping for something like this, right? Where we add feature set of these guys. We're like, add me float 64. Okay. And then we're like, B install artifact shader, right? Let's just see what that does. Let's just see. I was more highlighting the Arch SPIRV 64. That's fair. But I think that you should still be able to have 64-bit floats on 32-bit platforms. Wait, what the fuck is he mad about? He seems to be mad that I tried to use LLVM. Which is funny, because he should be using LLVM. But that compiles now. Which is interesting. And then I guess we need to change it so that this links to the right spot now. SPIRV test, zig out bin shader here. Okay. Okay. So now what? I guess we start trying to bring this shit back. Right, so we kind of fix this solve cubic viete thing, which means that like we can kind of start working our way up. Solve depressed cubic. Which surely, oopsies, you know, he's not going to be happy because the use of buffer here is a no-go. So A, A, B, perfect. So fucking stupid. But you know, it is what it is. 299, he is like, yo, can we have like, wherever we wrote invalid before? Oh, that was for something else. So can we do cubic solution, maybe return const empty is a undefined. Len 0. There we go. So who was pissed again? It was at 305. I guess we like this. Yeah, I guess that's a good point. This should be this. Uh-huh. 298 is like This should just be replaced with a return here. A is this. B undefined. C undefined. len1. Okay. Okay, we're getting farther. So now we should be able to have solve cubic. Let's kind of work our way up. So this guy needs, c dot start, maybe a few more parameters. Again, more of these guys are using that buffer, which he does not like. This is A, B, A. Maybe, is it here? No. 344. Ah, I see. Ret A minus equals shift. B, C. Perfect. Perfect. Solve quadratic is returning an optional, which is a no-go. So we kind of do this. That's valid. And this is undefined, undefined false. This is true. Now he's like, yo, what the fuck? I guess we want, can we just do this instead? T wool. Beautiful. Now he's like, I don't know how to fucking deal with that shit. So true. So here we'll say if roots 2 return ret, okay, and then this is going to be roots 0, roots 1. Perfect. Holy shit, it compiles. Okay, so now we should be able to go, like, walk up the call stack a little bit more. Solve Bezier T for Y. It compiles. It freaking compiles. So strange that optional of all things was missing. You'd think it'd be implementing would optionals be rather simple. Yeah, you would. Now segfault seems likely, right? I would like to. I guess we just have to keep going. We just rip the whole thing, huh? Cubic Bezier dir at T. Fuck it. This. Oh, beautiful. That is so straightforward. Well, I mean, like, straightforward in the world of, like, amount of code I have to copy paste. Not necessarily in terms of implementation, but it's not that bad. Just a little derivative. Just a little derivative. And so, if we find this thing, we say we have like 3 things to write here, right? So this is, I guess, plus I here. Okay. And then we need to get cubic Bezier x at t here, which is not implemented yet. Slope is good. Valid is 1. Beautiful. Okay, so now we just have to implement that one more thing. Cubic Bezier x at t, which again, just a fucking ton of lerps. Easy copy paste. What do we think? What do we think? Chances of this working? I'm giving it 20%. Holy fuck! Holy fucking shit! Those fucking cubic Beziers are so fucking outlined right now. Look at that shit. That's fucking awesome. That's actually really fucking sick. Yeah, suck it segfault, we don't do that in here. Yeah, at least this time. All right. That brings us to the 2 hour mark. Merged with yesterday's VOD, 3 hours. So I think this is kind of like a nice break point. I think that we have learned that this is still a lot of work. So there's enough work to do one more stream on this to get the fill in tomorrow, maybe even two. So I think we call it here. I might try to do some off-screen cleanup of this stuff and like look into the things that aren't implemented. It might be possible to implement some of this stuff. Like what I need to look more into why I can't write a buffer, for example. Like that seems like something that should be able to be done. So yeah, I'm gonna see if I can like write the code here a little bit better, and then maybe try to find a way to like import stud, like import the code correctly. But we'll see. We'll see. Yeah, we're making good progress. Slower than I would have liked. But yeah. HEC author also hung his GPU all the time. I was waiting for the stream crash. Oh yeah. It does seem like if we do that, this is running on the same GPU that is rendering my desktop and OBS. So that would be a problem. Are you planning to make a SPIRV PR for the missing stuff? It depends on if I do it. I did PR. I got the first fix that we made yesterday approved. So we might see a couple more go in. Really depends. I'm gonna take a peek. I just don't know if this is like fucking hard or not. You know what I mean? So we'll see. All right. Anything else? I think that's it. YouTube, peace. Twitch, let's find someone to raid.